Hello there, welcome back and welcome to part 45 in my build log series of the Trumpeter 1 to 200 scale model of the Titanic. Today I am working on a few different things. I'm doing the fault finding mission that I said I would in the last episode, checking why the LEDs at the very back of A deck are not performing correctly. I'm also building and installing the power supply that I'm going to use to regulate the LED's voltage. This supply is going to bring the voltage down from battery voltage, which is 12 volts, down to 11 volts, which just makes the LEDs that little bit less bright and makes them look a bit more appropriate for a ship in 1912. I'm also going to do a couple of other little sundry jobs, things like installing some pillars on A deck as well. So, with all that to come, without any further ado, let's crack on. So, a bit of debugging. So what we have here is a circuit which has 12 volts across it, 330 ohm resistor, 4 LEDs in series, back to negative. So not a very complicated circuit at all. The only thing that really makes it more complicated is that it's all very small. So what I'm using to test this is a multimeter, and I've got it set to a beep mode. So when there is continuity, when there's very low resistance between 2 points, it'll beep. So for example, if I put my probes on the same side of the resistor, you'll see there's virtually no resistance and so it beeps. If I put my probes across the resistor, there's about 328 ohms of resistance, so it doesn't beep. So I've already tested the connections from the incoming lines out to where they actually pick up power from the batteries, so we know that from here, that way, we're absolutely fine. So the fault lies somewhere around here. So the first thing I'm going to do is I'm just going to test continuity between all the soldered joints and between all the wires. If these all prove to be good, that probably means that we've got a fault with one of the LEDs, which will have to mean taking out this piece of plastic here, replacing an LED sequentially until we get a circuit that works again. So let's crack on. So I'm going to put my probe here on the wire and my probe here. Just need to try to get a bit of bare metal. There we are. Probe there, and probe there. So we've proved this red wire here to down to here. Let's go from here to there. Yep. It's all good. Right. Okay, so let's test this joint here. That's good. This joint from here. Where's my test point? Here. Here and there. Yep. And then let's go on here. And there. That's okay. I'll move my head out of the way in just a second. Right. So whilst that proves that there's no problem, what it also means is that in all likelihood one of the LEDs has broken. Now that's disappointing because what I'm going to have to do is I'm going to have to take out this piece here will just lift off, and then I'll change out one LED at a time, put a voltage across it, see if the circuit works again, and we'll go from there. And hopefully, you never know, we might get we might change the right LED on the first go, in which case we only waste one LED. But as I explained in previous videos, it's quite difficult to test LEDs to see if they work, particularly when they're this small. If they were a bit bigger, I could just, put a bit of voltage across each LED in turn and see if it lit up. And if it didn't light up, that's the culprit, But unfortunately, because I can't do that, because these are so small, I'm going to have to take off the entire piece of plastic. So I'll crack on with that, and I will show you the results in just a second. So I'm just sort of getting ready to put new LEDs in this area. And what I'm going to do is I'm going to drill out these holes again, because the backing of them has a fair amount of sort of build-up of glue and stuff now. And the reason I'm doing this and the reason I'm showing it is because I'm trying to sort of emphasize that a lot of the time when you're making a model, things won't go right first time. Things probably won't go right second time. And so you may fairly regularly find yourself in a position where you need to rework something. And 9 times out of 10, even in this situation where it looks really pretty minging now, there's lots of glue sort of gunked up everywhere and stuff, 9 times out of 10, irrespective of how bad something looks, it's still very, the situation is still quite retrievable, you know? So I'm just going to drill out these holes one by one, which will take a fair while because they're full of CA glue now, but I'll, you know, go slowly. And then we'll fit new LEDs behind, and that should give us a good result again. Now, because this part's been handled a fair amount, it's become a little bit sort of grotty, and it's just not quite the nice white that I would like on the deck housings for the ship. So because of that, I'm just going to go over it once again with a little spray of paint. Nothing major, but just a little sort of, a really small little, just like almost like a facelifty kind of job, really. Nothing major, as I say. So what I'm doing in advance of that is I'm just masking up all the windows. And this is quite straightforward, really, because all you need to do is pop a bit of masking tape over the top and then feel for that sort of gap where the window actually is. And just cut along there. And then you should, theoretically, be able to peel away the masking tape. And there you are, you see you have 2 windows really nicely masked. So quite a simple way of doing it. If you wanted, you probably could hand paint these, but as I say, I tend to find spray painting gives you a better finish. Remember, T. T is essentially the reason why this model's come out the way it did. So I'll just do one more, then I'll go into time lapse, because once you've seen this, you know, it doesn't really change. So there we are. So here I am doing the rest of the windows. Just for continuity's sake, I'm not actually showing me painting this part, so the next clip is me removing the masking tape, having painted. So I'm just removing this masking tape now. You see underneath we still have our windows looking nice and pretty. And by repainting, we've just managed to sort of spruce up the part a bit. We've made it look a little bit more appealing once again. Looks a little bit less like it's been handled perhaps more often than it should have been, you know? There we are. Right, so I've just been looking at methods of conditioning the power from the batteries for my LEDs, and this is what I've come up with. So this is what's called a switching regulator. It's not exactly the same as a power supply, but in essence you can look at it as pretty much the same thing. But you can see it's got a fairly wide range of output voltages. You can go from 5 up to 15 volts, which is lovely. And it's got a nice input range as well, 10 to 30. The input range for me isn't as important because I'm using batteries, so a fully charged lead acid is going to kick out about 13.2, and when fully discharged it might drop down to about 11. So the range there, 10 to 30, is going to be absolutely fine. So it comes on a nice PCB board, which is quite useful. If we have a look at the data sheet, 3 amps capable of kicking out, so that should be plenty for the LEDs that I am using. And if we have a look at the pinout, nothing much exciting here. If we have a look at the pinout, 5 pins. It's got a remote on off, which I won't be using. Voltage in on pin 2, that's this one, so that's going to go to my batteries. Pin 3 is ground. That's the central pin there, that's pin 3. And pin 4 is the output voltage. That's pin 4 there, output voltage. So that's what's going to be sending current out to my LEDs. Bear in mind that there's a shared ground, so this ground is ground with respect to the battery voltage coming in and also the output voltage. So this isn't an isolated power supply. There's also a trim function. Now this is quite important for me because as a default, if I just wired this up without anything external, this would kick out 5 volts. So I need to use a trim resistor, and I need to connect that between pin 5 and pin 3, and I can use that resistor to tailor the output voltage to what I want. So what I'm going to plan on doing is I'm going to get a variable resistor with a little knob on so I can twist and I can sort of calibrate the output voltage that this produces for the circuit, and that should give me a bit more flexibility. It means that I can reduce the voltage if I think the LEDs are still too bright, and equally it means I can change, if in the future I change my batteries, which is entirely possible, I can again sort of recalibrate the circuit as and when I require it. So that's what I'm going to do. So I'll get one of those ordered up, and I'll get a few other things ordered up as well, and then we'll see about sort of testing it and getting it set up. Now then, what I've got here is a piece of test board or strip board or prototyping board, or really whatever you want to call it. But essentially all it is a piece of circuit board where all the tracks run straight down, and you've got loads and loads of holes in it to mock up circuits and generally prototype. Now normally when you're using a circuit board like this, you would insert your component the other way around, so the body of the component would sit on the fiberglass side and the legs would poke through onto the copper tracks. For some reason with this particular supply, that's not an option. The legs aren't spaced the right distance apart, so the only way I can actually get contact with all the legs onto all the tracks is by putting it upside down on the board. So that's a wee bit of a non-standard practice, but I mean, it's not the end of the world. It's, as I say, just a wee bit non-standard, but it's not really an issue. So all I'm going to do is I'm going to solder this up, and then I will crack on and add another few components onto this test board so that we can start to get these lights powered properly. So if you don't solder often, the general principle is to put the soldering iron on the track, touching the leg of the component. That heats up both equally, so the track and the component are equally heated. Then just touch your solder on. Wait until the solder flows around the whole joint, and there you are. What I'm going to do here, what I'm going to try to do anyway, there we are. So you can see that now this component is fully soldered onto here. So each one of those tracks now corresponds to one of the legs on this component. So nice and easy. So what I've done is I have now attached 2 wires to this. You can see that they go up into here, and there's some strain relief just to make sure that when, or rather if, although let's be honest, probably when they get yanked, they don't get pulled straight out of the circuit board. So what I've got here is I've got a 12 volt battery, reminiscent of what you would see on the actual Titanic. And I'll just pop my multimeter in the way so that you can see what's going on. So what I am going to do is I'm going to test to see how the power supply is performing. What I'm expecting is that at the moment it'll give out 5 volts. So it'll take 12 volts in and it'll give out 5 volts. Just measuring across the battery, and you can see that there we have 12.89 volts. So that's a fairly healthily charged battery. Right. So it's neutral in. And there's the positive. So now when I measure across the outputs of this power supply, I'm expecting 5 volts. So what do we get? There you are. 5 exactly, bang on the money, 5 volts. Brilliant. So we know that it's working. Now what we need to do is we need to add an external resistor, and what that'll do is it'll tailor the output voltage to what we want, which in my case is 11 volts. So here we are. This is what's called a potentiometer. Now a potentiometer is essentially a variable resistor with a third output which is taken from somewhere along the resistor's range. So there's 3 legs on this beastie. That's the first leg here, and that's at one end of the resistor. That's the second leg, and that's right at the other end of the resistor. And this third leg is the variable position. And when I put a small screwdriver here and twist this white disc around, the resistance of this leg with respect to the other 2 will change. And that's how we get our variable resistance. So as before, I'm just going to solder this into position. Now this is, as I say, this is what's called test board. And test board is great because it means you can rapidly test circuits. But the issue, of course, and I'm sure most of you will have spotted it, is that these tracks run all the way along. So in some places, you don't want continuity between the tracks. So what you do is you get a drill, and you drill away the copper connection. So you can see there that my drill has drilled out that track, which means that there's now no longer continuity along that line. Right, here we are, we're back. And here is the circuit now finished. I had to change out the potentiometer. The one I used originally didn't have a big enough range. But that's exactly why I bought a selection, so that I could work that out after the fact. So what we've got is a very simple board with the power supply on the top and the potentiometer on the bottom, and 3 wires coming from it. We've got the red wire, which goes to the 12 volt terminal of my battery, the black wire, which goes to the 0 volt terminal of my battery, and we've got this yellow wire, which I may replace later with a slightly thicker one, but anyway, for now, testing purposes, this yellow wire, which is my supply voltage, which I'm sending out to the LEDs. The black wire is 0 volts for both. So this isn't an isolated power supply. The black wire is 0 volts in relation to the 12 volts from the battery and my output voltage. So you can see at the moment, when I put my multimeter across it, we're getting 5.82 volts. And I'll just demonstrate for you the effect of the trim resistor. As I turn the potentiometer, you can see that the output voltage rises. And there we are, that's about where we want to be, isn't it? .4, 10.6, it's quite tricky to get this exact. And of course, resistance is a unit that will vary with temperature, humidity, so the ability to be able to calibrate this relatively routinely is probably quite useful, really. So what I'll do now is I'll power this onto the actual, put it onto the actual boat, and I'll see if this is capable of supplying all the LEDs I have. Should be capable of pumping out about 3 amps, so we'll see how we do. Right, there's one final thing I need to do before I declare this an actual success, and that is I want to check to see how this board reacts, or rather how this power supply reacts to its input rising and lowering in terms of voltage, because when the ship is on the water it probably won't get a perfectly consistent voltage. So this is a lead acid battery, and these are this exact same type as the ones that I'm using in the model ship, and the way a lead acid battery works is that it uses a chemical reaction to generate a current, but when this is fully charged, it'll probably give you, despite being nominally 12 volts, when it's fully charged, it'll probably give you more like 13. And you know, sure enough, if I put my multimeter on the terminals of the battery now, you can see that a 12 volt battery is actually giving us pretty much 13 volts. And equally, when this is fully discharged, we're probably going to see around 11. And that is, it's not a huge difference, and it's certainly nothing that my my transmission and receiver circuit needs to worry about. It's nothing that the motors of the ship will need to worry about. Certainly nothing that the speed controller needs to worry about. But it will make a big difference in terms of the brightness of the lights. And so one of the really nice things about having this is that I'm sort of providing another layer of buffering against that. And certainly theoretically, this should give an output practically irrespective of its input. This can take an input all the way down from 5 volts up to 30 volts and give me something else. So this should give me a bit more stability. So how I'm going to test this is I'm using my trusty power supply at the moment, and what I'm going to do, I've set this at 13.1 volts, and that's what my board is being supplied with now. So imagine that this is my ship fully charged, ready to go. What I'm going to do is I'm going to measure the output that this gives me with my multimeter, and I'm going to lower the voltage that my power supply is delivering. So essentially what I'm modelling is, as the batteries deplete their charge over time, what happens to the output of this. So to measure it, I'm putting my neutral terminal into the neutral terminal of my power supply, and my positive terminal goes onto the output, and you can see that at the moment we're getting outputted 11 point, if I can hold the probe still enough, there we are, 11.19 volts. So if I now lower my power supply voltage, I'm expecting this will drop off a bit, but I don't think it'll drop off as much. So we go 12. So there we are, we've dropped down now by a whole volt on this. We've gone down by about 0.3 of a volt on my power supply board. We'll go down again to 11. And there we are now, starting to drop off a wee bit. So for 2 volts worth of power, of voltage change coming from my actual ship's batteries, this is only going to drop out by about 1 volt. So that's quite helpful. That's genuinely quite beneficial. What that's telling me is that this will cushion the voltage change across my batteries quite happily. What it's also suggesting though is that maybe what I should do is I should set the trim resistor on this so that it's giving me a little bit more than 11 volts when my batteries are fully charged, so that when they drop off it gives me a little bit less than 11 volts when the batteries are not fully charged. So I'll sort of average out somewhere in the middle. And that's quite a nice idea really. I think you know, lights on old liners, I would be astounded if lights on old liners were consistently at exactly the same brightness. I imagine that the electrical generators on board probably would have outputted relatively different voltages. So I think that's probably not going to be a big issue. Right, so what I need to do now is, well, firstly I'll turn this power supply off. Unplug my board. What I need to do now, we're pretty much ready to go on this. The only thing that remains is I want to get a thicker wire for my output, because this is very thin and I'm just conscious that it's going to be probably a bit too thin really. The red and black are fine, these are quite nice, but this is going to be a bit too thin. So I bought some more wire, that'll be coming in the post, and then I'll wire this up, get it on the ship, and we'll see how it goes. Right, so I've now plumbed everything back in. Here is the new power supply. As you can see, the lights are on, and more importantly, they are a wee bit less bright than they were before. So just to sort of prove what's going on, what I'll do first is I'll show you the supply going into my power supply. So let's do that. And you can see there, 12 volts. And then I'll show you the supply going out of my power supply into the lighting circuit. If I can get my probe on it properly. There we are, 11.15. So, as you can see, I have now successfully managed to reduce the voltage that my LEDs are functioning off. In other news, I have also reattached this aft section, and you can see that the LEDs which I've reinstalled are in place and they look very good. Do need to do something about this one that's a wee bit less bright than that, but we'll have an investigation into that and see why that's the thing, why that's happening. But overall, I'm very happy now. It's difficult to tell without a comparison, but it is quite noticeable to me that these LEDs are now quite markedly less bright than they were. And that's really good. They look a bit more realistic now, and they are also going to last a fair bit longer. So I'm wanting to get the other support pillars on A deck done, because most of the work on A deck is finished now. And it's just becoming one of those little jobs that needs to be done, and I haven't yet got around to it. So what I'm using is this 0.8mm brass bar from Albion Alloys. And this is the same company I used right at the start of the project when I was doing the rudder. If you remember, I had to buy some tube and some rod then, and I went to Albion Alloys and they're very good. The KA set does come with 0.8mm brass rod, but I suspect I probably used too much of it in the wrong place or something like that, because I didn't. The amount that they supplied me with hasn't covered the entirety of the ship. So I've just bought some more, and to be honest, that's not really an issue, because this is the kind of stuff that you'll end up using it on loads of different projects anyway, so there's no harm in having a bit of that in stock anyway. So what I'm doing to start with is I am just applying my normal metal prep, and then I'll be able to paint it white, chop them to the right length, and insert them into the decks in exactly the same way I did on a deck before. So it's a fairly simple exercise, this, isn't it? It's just simple, easy painting. Good, so I'll do the other one and leave this to dry, and then we'll paint. So what I'm doing here is I'm going to add the supporting pillars that sort of stood in these alcoves to support the next deck up. And so what I'm using for this is I've got some 0.8mm bar, sorry, 0.8mm rod. That's a bit of it, and there's a couple of other bits over there. And I'm using Encyclopedia Titanica. So you can see, if we have a look, you know, you can define how many pillars you need. On this bit there's 1, 2, 3, 4, 5, 6, 7, and that refers to this section here, so we need to measure out and get 7 pillars in this area. I've made myself a little height gauge, which is just a measure of the distance from here up to the ceiling above, which means that once the pillars are in place, I can just check the height gauge, make sure that everything is a-okay and we're not going to have anything fouling on the deck above, because we certainly don't want to be introducing problems like that. So what I'm going to be doing is I'm just going to be measuring out first and then drilling holes, inserting these and gluing them in. And that'll be another nice little feature of this deck done, and it'll be another step towards finishing off a deck. So I'm starting off with the easiest alcove, and this is the one between the reading and writing room and the first class grand staircase. And you can see that we only need 2 pillars here. So what I've done, and I am just using a trusty calibrated ruler, and you can see that I've marked out my locations for these 2 pillars here. You can see that from Encyclopedia Titanica, these pillars run almost adjacent, they run almost in line with the deck housing of the grand staircase. So that's how I have defined these here. And I can also now, when I'm drilling, I can use these the lines printed on the deck as a way of making sure I'm actually getting these in line with each other. So I'll get these drilled out, and then I'll get some pillars put in there and glued up, and then we'll move on to the slightly more challenging areas where there are more pillars. So what I'm doing here is I'm drilling a 0.7mm hole with my trusty hand drill. And this creates a really tight fit for the brass rod to fit into, which goes a long way to making sure that the brass rod stands perpendicular to the deck. Now you can see that because we've measured out carefully, we've taken our time over it, we're getting a really nice close finish. But we're not getting anything that actually is going to foul. You can see that these pillars are just a bit lower than the actual height of the boat deck above them. But when viewed from any kind of distance, they look really good. And that's exactly what we're after. So here we are now, and the ship has lights, now powered by 11 volts rather than 12. So I'm very happy with this. It is notably darker than it used to be. If we have a look sort of down the promenades, if I can get my camera to do such a thing, you can see that those lights down the promenade are significantly less bright than before, and similarly my camera is now actually able to pick up detail inside the rooms, which previously it wasn't able to do because the light was too bright. So we've genuinely managed to reduce the lighting quite significantly, and as a result we are able to see into rooms a bit better. And also the model just looks that bit more realistic now. It looks like an older ship, and as you get further away, you can see that the lights have got less bright. It is hard. The camera does tend to sort of exaggerate the light a bit more, but I do think the effect is good. Also, you can see now we've got the pillars keeping up our upper deck. Notice I haven't firmly secured these decks down yet, so that's why the deck housing's lifted off a bit. We need some positive pressure pushing down on above, but I haven't done that yet. But you can see that those pillars are in place and they look very nice, and they do just add that little bit more sort of logic to the model. Before, there was an awful lot of space in this area, not supported. So those pillars just add a little bit more logic. They make the model make that little bit more sense, I suppose. So there we are, very happy with it. And of course, at the back, we also have those lights there now. So, all very good. So there we are. That is all I'm going to cover in this video. I hope you've enjoyed it. Sorry it's taken so long to get the video out. My modelling always takes a hit around Christmas. I tend to make quite a lot of presents at Christmas for people, and of course that tends to sort of detract from the amount of modelling I can do, and so other projects rather suffer as a consequence. But that's life, and I'll be back on it with a bit more vengeance in January. I'm pretty happy with what we've accomplished in this one. I have to say, I was genuinely a wee bit worried when that sort of quartet of 4 LEDs on the aft of A deck broke, and even more worried when I found that it wasn't the wiring, it was an LED that had gone. And I did start to think, crikey, have I been running my LEDs at too high a voltage? But I mean, I've gone back over my maths and my calculations, and I'm pretty happy that I'm not. But it wouldn't be outside of the realms of possibility that I've just dropped a massive clanger and I've made a mistake and I have been running them at a higher voltage. So it is a genuine relief to know that I have a purpose power supply in there which guarantees that I'm not going to be running my LEDs at too high a voltage from now on. So that's a bit of a comfort, really. I'm also very happy with the pillars. There's not a huge amount more to do on A deck now, really. Obviously, there's the A deck grand staircase at the front, which needs to be done. I want to put, general shipboard paraphernalia, deck chairs and stuff like that. I need to do a bit of painting of the gunnels to, make them look like they had teak gunnels. And I need to add people and a bit of signage. But, the lion's share of the work is now done on A deck. Which is very good. So this will probably be the last video I do before Christmas. I might get another one in, but it just depends on how busy I am at work and how much other stuff I've got to do, really. So if I don't produce any more videos, have a very nice, happy Christmas, and I will see you back in January. Any questions or comments, whatever, whack them down below, and I'll do my absolute best to get back to you. And have a good one. Bye for now. Also, like and subscribe.